Welcome on Stage Off, Day 1. We have our speaker, Alt F4. And we are going to get to know DNS, how the whole thing works. It's easy to forget, like we type into our address bar or in some text field like example.com and magically some website appears. But that's only the first part of the story. There's layers and layers underneath that. So the first part is we get to know how the whole thing works. Important stuff. And also if you look into how things work, you encounter problems and issues. And then you can look how to improve on them and do it right. And maybe even secure and eventually decentralized. So we don't have to rely on some big corporation. So, have a round of applause for Alt F4 and let's hear it.
Okay, so hello everyone. So I will start with a question. Who here has a domain? Okay. Who has more than one domain? Okay, who understands how the thing works? That's a bit less already. Okay, so first an introduction. Hello, I'm Alt F4. I'm a network engineer. I do things with stuff. Some curse, some less. But yeah, I knew what DNS was working kind of, like a little bit everyone, until something happened at MCH. This happened. Q, which is a person that is working in the NOC of CCC, did a talk about how a registrar works. This seems like something dark magic. You know, that you're not supposed to know that. You just buy your domain and whatever happens above, like, who knows? And learning about this, I was like, huh, there is maybe a little bit more about this. I should dig about it. Like her, like she said, this was a mistake. And yeah, this was indeed a mistake because it goes really, really far and it never stops. So how did it start? First off, we started with the host.txt file. You probably all know etc host on your laptop or your computer. You can put a host name and then an IP address. And if you ping the host name, it will reply. That's how it worked in the ARPANET days. So you had 4 computers. There was one person managing the entire system. And you would just ask for the new version, download the new version, and now you're up to date. It ended up with the fact that they had a FTP server where you could basically download the latest version, and between the time that you start the download and you finish the download, it was already outdated. At this point, they started to say, maybe we need to do something better. They started with implementing the DNS system. That was in 1984, so there are some RFCs in 1983, some in 1984. And that was when it was defined. There is a .arpa zone. They took all the host.txt file. They said, this is now considered legacy. This is all in .arpa. After that, they created, well, Bind got created, Berkeley Internet Naming Daemon. Then they created ICANN. Then the first internationalized domain names. Germany has some with weird letters inside of it. This is supposed to be for people that don't have a language that is purely ASCII, aka not only English-speaking people. So this was a big deal, and then they started adding new sponsored TLDs. The sponsored TLDs like .work, .radio, .aero, all those things got added. What most people know about DNS is the resolver part. Like, oh, get faster DNS, put 1.1.1.1 Cloudflare, woo, so fast. By default, your machine will get a DNS server from your DHCP. You connect to your Wi-Fi, and you get an IP address for the DNS resolver. The DNS resolver is most oftentimes your internet box. So when you make, hey, I want to know the IPv6 address for af4.be, it will first ask to the box. The box will either say, I know it because someone else queried it in the network a few minutes before, so here is the reply. I did not forget about it. If it doesn't know about it, it will forward to the next resolver, which is most oftentimes your ISP. Or if you modify it, you can put Cloudflare or Google or Quad9 with 4 nines, which is the same thing but with privacy. So if they don't have it in cache, they will have to go into recursive resolving mode. And this is what most people know about. You have the root zone, then the TLD zone, and then your own zone. It will first go asking, hey, to the root DNS, hey, I need to have the IPv6 for a4.be. And the root server will reply, I have no idea what you're talking about. It will then say, I can help you because I know .be, so maybe they know something about it. Then your resolver will get the reply, hey, these are the NS servers, the name servers for .be. It will then reinitiate another connection to .be asking, hey, do you know about the the IPv6 address for a4.be? .be will say, no, I don't know that, but I know a4.be. There you go. It will then reply the name servers for a4.be, which will then reply, here is the IPv6 address, there you go. So to make that work, because on paper it's funny, but yeah, you have a few more things to see. We start with records. You have the SOA records, which is obligatory, which is basically, hey, I'm authoritative for this domain. You can talk to me, I know about it. Then you have the NS records, which are the name servers, the A records for IPv4, Quad A for IPv6, MX for mail servers, because yeah, that's also managed by DNS. SSHFP, that's a funny one. You know when you log in into SSH and it says, hey, I don't know this device, do you accept this key? Well, the SSHFP allows you to put that fingerprint inside your DNS, so it will still ask you about it, but it will also say, hey, this is the same signature as in the DNS. This is probably legit. This is an interesting record, not often implemented, but can be cool. The CAA is something else that is also very interesting. If, for example, you want to say, I only want to allow VeriSign certificates for my web servers, you can enforce that into the CAA. And basically, if someone asks with a subdomain, hey, I want to have HTTPS, let's use Let's Encrypt. Let's Encrypt will see, hey, I'm not supposed to release a certificate for this domain. It will drop it, it will fail. This can be interesting into bigger networks. Maybe Let's Encrypt not the most interesting one in that case, but it exists. The TXT records, which is often used when you have some cloud implementation to validate, hey, I own this domain. They will ask you, put this password into a TXT record under this record. Then you can get raw text over DNS. There are some people that's made backups into DNS like that. Then you have the CNAMEs, which is the canonical name. A lot of people have already used that. Basically, you have one fully qualified domain name that says, hey, this is this machine. Now you have other pointers that go there to point, for example, to multiple subdomains to the same names, to the same web server. So you don't have to copy-paste the same IPs over and over and over again. And if you need to change that record because you migrated the server, you change one record and all the rest follows. In practice, it looks something like this. This is a template of a zone file, a part of one of my zone files, in fact. So the SOA records, you see ner.a4.be. This is the primary server. This is, I'm the master, I own the zone. Then the hostmaster.a4.be. This is an email address. You're supposed to replace the first dot by a @ so it becomes hostmaster@af4.be. Every domain has one. Is it monitored? Maybe. It should be, but that's how it is. Then the serial number. When you change the zone, the serial number needs to be incremented. That indicates to the resolver, hey, this zone has changed. And that also allows you to track which name server has the up-to-date version of the zone. If you change a record and you don't change the serial and you refresh bind, it will not do anything. It will just not change. The refresh is the time that, that the slave will wait before reinitiating a query to the master and ask, hey, do you have a change? If that doesn't work, it will wait for the retry to retry and transfer the zone. If that fails, after the expire timer, it will just stop answering the zone. So that means that you can have a few hours with the primary down and the slave still up that will just answer queries. But if you wait too long, the entire zone will eventually fail. And the negative TTL, negative time to live, as you can see before, in front of every record, you have a time to live. This is the time that the resolver is supposed to keep the record in cache. So it will not forget for this amount of seconds. If someone makes another request in that timer, it will not need to do the recursive resolution again because it's still in the cache. The negative cache means that the resolver has to keep in mind that this record did not exist. So that when you spam to say, hey, I want this record, if there is a negative TTL set, there is no use doing that because it will stay in the cache longer. Underneath that, you have the DNS servers. Those are not necessarily required in your own zone. It's considered best practice to have the same thing in the parent zone than in your own zone. So you're supposed to put them for some TLDs. I know .fr and .be do require you. .de, I'm not sure. The TXT SPF, so that is for email. If you send an email and you don't have an SPF record, welcome to spam. So this is the only way to get through. You need a SPF record. Then the MX records, you have a priority underneath, 10 and 20. 10 will be the first priority. If that one doesn't answer, it will try the next one. Then you have the CAA, the one that I was explaining. My domain only allows Let's Encrypt, the A and Quad A, and the SSHFPs. I was talking about the master and the slave servers. When you update the master server, it will send a notify to the slave, telling, hey, there is an update. So the slave will initiate a zone transfer, either AXFR or IXFR. AXFR is I transfer everything of the zone. IXFR is I only transfer what has been changed. And then the master will reply with the changes. This can also work without the notify. That was the refresh timer into the SOA. So even if the notify doesn't go through, it will retry later. So at this point, that's what we have. We have the name servers that go recursively back to the top, and .be knows about my server, the root zone knows about .be. There is still something missing, because great, the root server knows that he needs to forward to nsset.be. How does he know who is nsset.be? Because he does not have IPs. That's where the glue records come in. The glue records allow you to put the IPs of what is supposed to be your name server into the parent zone. That way it can already resolve and then go recursively down. If you don't put a glue server, if you don't put a glue record, it will not be able to resolve and you end up stuck. This is often forgotten, especially when you have separate slaves, because the slaves, they reply, the master did not. If you lose the slaves, your zone is down. So you completely lost the redundancy. After that, we have DNSSEC. This is a topic on its own. I could make 2 talks about it. This is, there are a lot of things to say. Basically, DNS was made in 1984 when cybersecurity was not really a concern. So basically, you could spoof the reply of an authoritative name server. If you spam enough, you can say, hey, this is totally the domain, this is totally the record that you asked. And the name server, the recursive resolver, will accept it. It will just send whatever. People say this is not a problem with HTTPS because you have the certificates. It is a problem for the mail servers, though. But we resolved that with centralizing email. Everything is in Outlook these days, so people considered it not to be a problem. But DNSSEC works with making RR sets, so a set of records. It will do the MX, DA, and do them separately. It will sign it with a ZSK. A ZSK is the zone signing key. The signed version would become the RR SIG. And then it will sign the key SK, it will sign the ZSK with a key signing key, which will also become an RR SIG. And then you need to make a hash of that key and send it to the parent zone. This is your DS record, which makes that now you have the DS that points to the key SK, then the ZSK, and then you have the signed zone underneath. The reason for that is if you change your zone quite often, you might be able, with a lot of compute power, to find out what the ZSK private key is. So you just sign it again with the key SK, and you can rotate the ZSK independently without needing to touch the registrar again. So you can basically leave it on autopilot. If you start with your zone, then it goes back up, back up, back up. This makes a chain of trust, meaning that if anything is broken in the chain, it is useless. How do we trust the root zone? This is what they call the trust anchor. So in your resolver, there is a key file that takes the public key of the root zone and keeps it locally. This is rotated every few months. You probably all heard about those YouTube videos about the 7 people that can disable the internet because they have the keys. And these keys, well, yeah, they exist. They have that at IANA, the key SK ceremony, and basically you have 7 people that reunite with the keys. You have other people that know the technical stuff and that will make everything official. And every few months, they will make a new key. And then they will rotate it. And it will progressively get updated over the next few months, and that's how they rotate it. This is all public information on the IANA website if you want to watch them. I think the last one was a video recording of 8 hours, where they were basically doing the switchover, the rollover of keys. You have multiple algorithms in DNSSEC. There they are. That's a lot. One might assume the most complex the algorithm is, the better, more security. I would theoretically agree, but this is not how it is. You need to have support everywhere. So that means that bugs need to be found and that a lot of people need to use those algorithms. So these days, what is considered as secure algorithms is Algo 8 and Algo 13. Algo 8 is pre-quantum cryptography. It's RSA, and Algo 13 is P256. That's post-quantum. So right now, almost all the TLDs, and even IANA, I think it's next year, they plan to rotate to Algo 13 so that they are future-proof. But yeah, don't just use whatever. Now that DNSSEC is over, let's speak about the root servers, all 13 of them. As you can see, most of them are based in the US, except NetNode, RIPE-NCC, and White Project, which, well, White Project is in Japan, NetNode is in the Nordics, and RIPE-NCC is everywhere in Europe. 13 might sound like not a lot. They are theoretically more than 13, because this is, for example, the propagation of K root. This is the RIPE-NCC server. As you can see, you have many of them a little bit everywhere around, and they use a technology that is called Anycast. Anycast, you can see that as a highway. If you're on a highway and you need, for some reason, a Shell fuel station, only a Shell, you have many Shell fuel stations on the highway. It's not only one of them. The only identification you have is a Shell fuel station. Anycast is basically the same thing. You have multiple points on the internet where the routes go left and right, and they will, for example, if you go to Cloudflare 1.1.1.1, it is anycasted. So there are many points in the internet where they have the IP 1.1.1.1. You will escape your ISP and go to 1.1.1.1 as fast as possible in the shortest path possible, because they're everywhere. The downside is 1.1.1.1 cannot ping 1.1.1.1, which is another one than him, because it doesn't have more information. After that, you can also do, if you think that having a closed root DNS is not enough, you can have it locally. If you run the dig command in your terminal, you're able to print the entire content of the K-root server on your console right now. This allows you to basically have your local resolver have a copy and skip an entire step of the DNS resolution process, because you don't need to query the K-root. It's already there. It has a copy. This is the interesting thing you can do about the root DNS. More than that, there's not really much to say. So we're going to switch over to TLDs. You have 2 types of TLDs, the country code TLDs and the generic TLDs. The generic TLDs themselves are the sponsored TLDs and the unsponsored TLDs. The unsponsored TLDs, for example, you have .com or .net. Those were not sponsored. They were there since the beginning. And then you have the sponsored ones. You have .airbus, for example. You have .aero, .radio, .work. Those were all sponsored by a company that said, I really want this TLD. So if you pay enough money and you wait long enough, you might get your own TLD in the ICANN root zone. I think it was something like 370,000 euro. So definitely not for everyone. So how do you choose your TLD when you choose your own domain? You can take a name and then spread it over various different TLDs. This is a terrible idea, basically. Because, by the way, that's a cool domain, bro. It's still available if you want it. Because if you end up doing something like tiramisu, That's cool and all. But if you want to put your own CV on tiramisu, and you are sending that link to someone in HR, and that HR company turns out to be in a country that doesn't really like the country in which your TLD is pointing to, this might get blacklisted. Then you also have the search engine optimization. For example, if you look an internet line on Google, Google will tell you, hey, here are the available providers in your region. If you put any TLD because it's fun, you will get search engine optimized completely differently than you were expecting, because, okay, .so, yes, that's not in Belgium. It will just point somewhere else. Also, you might have other political problems. Some people might remember .yu from Yugoslavia. Or in the most recent times, you have .io. .io, which everyone was like, oh, IO, input, output, so cool. We are going to put all our domains in .io. Yeah, except that this one is it's not a general TLD. It's not a generic TLD. It's a country code TLD. And the country code TLD means that when this country code TLD is from a British colony and Britain loses that colony, .io is going to be decommissioned. At least that's the last news that we have. So now the people that only relied on .io, well, they will lose their domain. But then there are other considerations that you might have. Is having a local TLD might work very well locally. It might not work well everywhere. Here is a latency map between .net and .im. IM is Isle of Man, and I know a lot of people that have .im because also it's cool, you know, it's trendy, you take .im. It has terrible resolution time in South America, for example. So depending on where you want to resolve, you might have completely different results. You also have various different things because, like I said, all those TLDs are managed differently. They are not equal. I made a little website, tldtest.net, where you have basic statistics about DNS TLDs. You see that some TLDs don't even implement IPv6 on their own servers. Some have more some have less IPv6 than IPv4. Some don't have DNSSEC. You might say you don't want DNSSEC. If at some reason, if at some point it becomes a legal requirement to put it in, because like NIS2, they add regulations. If at some point you need to have it, and it is some foreigner TLD which does not have it, you will have to change your domain. This can be a major hassle. So consider your TLD wisely when you take your domain. And you also have the latency map for every single one of them that is printed there, measured by RAP Atlas, which is a network of probes that is spread worldwide. So with that, you can see the resolution time of every single of your TLDs in which you might be interested. Then we get to the real funny part, the second level domains. So how do you analyze that? You can either take a look at every single domain that you visit and look at, hey, this is how they made it. Or you can go even further than that and ask ICANN to send you the zone files of every single TLD. Well, most of them. There are 1,448 TLDs. They have the zone files available for 1,080 of them. There is a little button on that little portal, CZDS. You can go right now and download and ask to download those TLDs. There is a button that allows you to ask for permission to download all of them. And when you do that, they will say, OK, we've received your request to download said TLD. They will send you an email to confirm this for all 1,080 TLDs. The mail server was not amused, I can tell you that. But when you start analyzing this data, you start noticing a few things. So 1.05% of all the records that are available in those TLDs have DNSSEC. This is very low. Another thing that we can see is for .com, parked domains, domains that are bought so that you, for example, you buy pizza.com and then you want to sell it for a lot of money. That constitutes between 25 and 30% of the entire .com zone. That's a lot. Cloudflare has approximately 5% of all the lines in the .com zone file. I proceeded by lines. I need to have more algorithmic knowledge to be able to make more precise statistics. But you have approximately 5% of Cloudflare, 7% of Google, 2% of AWS, and 2% of NS1. If you add them together, that makes up 16% of the entire .com zone file. This is a problem. This shows a lot of centralization. If you happen to lose Cloudflare for a day, that would be a very bad time. Cloudflare is mentioned 98 times in .com. This has the potential of being a sitting duck attack. The sitting duck attack is when you make a fault, a typo into the NS records, and you're pointing to something completely different than your own domain name server. If it points to nothing, then it's okay. But if someone sees that and say, I will just buy the domain that that person typoed, and you're not DNSSEC validated, you can basically hijack the domain. And this will be very hard to monitor until it's too late. Then the last metric I saw was the size of the files. .com is 25 gigabytes of raw text. .com plus all the other TLDs is 34 gigabytes of text, meaning that .com is bigger than all the other ones combined. .com is managed by VeriSign. It's one entity. If VeriSign fails at one point, because they also manage .NET, this is going to be a very bad day for a lot of people. So, if you want to make a resilient DNS setup, you need multiple things, multiple providers. Because if you go at Google, okay, everything is on the AS number of Google, and if you think that Google just cannot fail, watch Facebook a few years ago when they went completely offline. This can happen. And even if your website is hosted on some other cloud providers because you have many people that, oh, I have a reverse proxy there, another one there, redundancy, and then you see that the DNS is hosted by 2 servers at OVH. If you lose that, you lost everything. You need multiple TLDs, if possible, managed by different entities. For example, at .be, at .eu, at .com, those are 3 different entities. If one of them fails, and you host other domains with other TLDs on the same servers, it will continue to work. Some registrars do that when they host your domains. DNSSEC can be a good thing. I ended up into multiple situations where some providers were trying to alter my zone. They cannot do that. With DNSSEC, if it's signed, they cannot modify it or it will just be invalid. Some providers got the memo and some entities got the memo, like Spotify.com, for example. So you can see they have 2 providers, NS1, which is IBM, and Google domains. This is great. So if Google fails, they have NS1. If NS1 fails, they have Google. So you remember what I said about the SOA of the different name servers that should be the same one to have the same zone everywhere? This is the result that you have with Spotify.com. Both servers, the ones at NS1 and the one at Google, are claiming to be the master. This is dirty, to say the least. But they are not the only ones. You can have GitHub.com, for example, that does that. You end up in this situation by having developers managing your zone. They don't know about DNS, but they know about APIs. So they will query an API, have a little internal portal, you create a record, and you push it to the API. You have 2 completely independent name servers. If they want to ever implement DNSSEC on that thing, they are going to have a lot of fun. So to implement it yourself, a lot of people are scared to implement them themselves because DDoS and stuff. You can have what is called a hidden master setup, where you have your own primary that is hidden somewhere on the internet. It's not publicly available, and then have your secondary name server that will make an XFR copy of your primary, and then go to any CAS cloud provider for DDoS and for better distribution. Hurricane Electric, if you have an IPv6 Hurricane Electric certification, which is free, by the way, will host it freely for you. You also have a lot of friendly fellow hackers that can host them for you. By doing stuff like that, you will have a more redundant zone than many of the big providers because you will be reliant on multiple ISPs. If one of them gets nuked, the other one will stay up. The configuration for that is not really that hard. Basically, for the DNSSEC, you have these few lines to add. For example.com, in master, you have to have a zone file. You allow the query from any or none, depending on what you want to do. You allow the transfer only by your slave. You send a notification to your slave. You activate inline signing because, again, DNSSEC is complicated. So you can do it with inline signing. It will be easier to manage. You don't really have to think about DNSSEC management with inline signing. DNSSEC policy, you refer to the policy that you created just before, and you need to specify the key directory. For the slave, it's much easier. You just make an XFR. So you tell them, you allow the notify from the master. The master is this, allow query from anyone, and you don't send it to anyone else. There you have a slave. It's really easy to spawn. Some practical tools you can have for monitoring that, because that's how it fails. The problem with DNS is that it's surprisingly resilient. You need to do a lot for it to fail. So one thing will fail, another one thing will fail, then another one, until the last thing fails, and then everything is down. So monitoring might be a good idea. Dig is a good command that I recommend to learn, because you can make very specific queries to every single name server that you want. Zonemaster.net, which is a very interesting website. You put the domain inside of it, and it basically starts complaining about everything wrong about your domain. DNSViz allows you to make a trace, a graphical trace, from the root zone to your domain. So you can see everything on the path, how it is secured, how it is referenced. It will tell you all the warnings on the path. And RIPE Atlas. I cannot recommend RIPE Atlas enough. If you want to have a look at it, do it. It allows you to make statistics from everywhere, from different AS numbers, from different providers. So you can see if you end up into weird situations. And also, they allow for automatic email alerting. So if one of your servers suddenly stops replying, you will get a nice email telling you, hey, this is down. And you will be surprised about the amount of people that have DNS servers that are down and did not even notice it for 1 or 2 years. And then bring us to the questions.
Yeah, don't be shy. So I have to say that was a very comprehensive and also very fun talk.
Thank you.
And now we have time for like eight-ish minutes for questions. I imagine there are some. Who wants to start? Wave your hand.
See one there?
Okay, I come over.
Hi. Thank you for the very good talk. I have one basic question.
Yes?
You lost me at zones. What exactly is a zone? Like you mentioned the different stages you go to, but what is a zone and when do you lose it? Like what does the losing mean and stuff?
Losing your zone can mean many things. So a zone is basically, for example, AF4.be is one of my zones. So the zone is basically anything there and underneath. So you can either host everything and all your subdomains into the same zone, or you can delegate a child zone. That's what we did at Hackerspace Brussels, for example. We have the machines that we connect to the Wi-Fi automatically get their own DNS record in.hsbxl.be. This is a separate server, so you can add other NS records saying in your zone, in.hsbxl.be points to those servers, and that's another zone.
Another question, maybe from the internet. We have, as always, our Signal Angel monitoring the live feedback.
Someone there had one.
Then I'll come over there.
There are currently no questions from the internet, so I guess you made it very clear.
Or very confused.
Thank you very much for your talk. I just wanted to ask you whether you'd heard of or had experience further with DNS updates. There's a project that I've just completed with Freifunk here for community networks and for edge service providers, where we provide DNSSEC with dynamic DNS issued by keys lodged into the DNS system, a system called SIG0. The project's called SIG0 name control and allows for decentralized access to DNS updates down beyond zones.
In your situation, where you have a lot of updates and and those updates might be managed by other systems that may or may not be able to sign easily, the approach of inline signing is perfect because it is basically able to take the zone, sign it, and then serve it on the fly. Was there another question in that area?
I think, yeah.
And in the meantime, there's a question from the internet. Harris likes to know how much effort does it take to host your DNS yourself?
Depend on how much research and development you first want to make. So if you take templates like the ones that I put there, it can take you from anything from 5 minutes to 2 hours to have it completely operational. And then it's surprisingly low maintenance, to be honest. I would still recommend making monitoring and backups, but yeah, it's surprisingly low effort, especially when you have slave providers that are able to take the DDoS. That way you're sure that nothing bad can happen.
Hi, so
Yes?
I have a question about SEO. So you mentioned that these kind of unique country codes have poorer SEO performance in some cases. I'm wondering about these mainstream ones like .com, .org, .net. What about them from an SEO perspective?
They are treated differently. So this is why you have weird points with, for example, .io. .io is a ccTLD, but it is treated by Google like a generic TLD. So they say, oh, this is generic. So if you search and the domain is in IO, it will serve it everywhere in the world because it considers it generic. But the country code, if for example you use .no for Norway, it will probably prioritize you if you're in Norway. If I'm looking for stuff like Telia in Belgium, it will not give me telia.no. It will tell me the .com.
So I think we have time for 2 or maybe 3 more
there.
questions. The signal angel signaled to me. So let's take that question from the internet for the moment.
Yes, the internet wonders how you make backups using TXT records. Don't your MTUs run out, or can it be split in multiple UDP packages?
Don't do that. So yeah, TXT has a size limit. So what I know is someone that made a DD image of his hard disk and then encoded it in base 64 and put it with the maximum character size inside the TXT records. This will work, it's very nasty, and a lot of slave providers will tell you, if you pass 10,000 records, we will just drop your zone, because they see you coming with that one.
So, is bind still the software to use, or are there better alternatives?
I use bind. I like bind. There are some problems with bind, but another very popular one is DNS, maintained by nick.cz, I think, or cz.nick. I never know in what way they are writing it. This is also a very popular one. Most of the things are still powered by binds. If you go on some commercial stuff, I forgot the name of that one. There is a solution that does DHCP and DNS that you can integrate one keys in hand box. It's also based on bind. So you can assume that it's still the standard. If it works on bind, it will probably work somewhere else. So that's a personal choice. There is Power DNS also that has a lot of traction, but I don't know much about it.
So, time for one last question. Any takers?
Yeah.
Yeah.
I'm glad I got the last question. Thank you. I'm interested in Splinternet. I'm trying to do research on the Russian sovereign internet, even though I'm not from a technical background. And there's a lot of speculation about if Russia cuts off its DNS, so National Domain Name System for some 3 domains, which is not astonishing in itself, but if they would cut off the connection to the K root, the RIPE NCC, and would it be technically possible to acknowledge other root servers?
Absolutely. Absolutely. Basically, you can consider internet governance as people holding each other at a gunpoint, because that is basically what they do administratively. They are managing resources administratively. Nothing theoretically prevents you from building a completely parallel internet. If they want to split it, they are able to do it. This is why when there was question in the beginning of the war with Ukraine to cut Russia of the internet, and people asked RIPE NCC, take their IPs back. RIPE NCC said, no, we need to remain neutral, because the second they do that, you have a splitted internet, and it will never be reconciled again. So this is a very touchy subject. This is internet governance, but they are completely technically able to separate their entire system. Nothing prevents them from doing so.
Thank you. So that's our time. And again, I think there's a really, really big round of applause deserved here. Thank you all for.
Thank you.